Hey there, this is Kurt Rosenfeld from CTI Data. In this video, I'll step through a rapid process for moving SQL data from a legacy cloud database, in this case Snowflake, to Databricks SQL. Such migrations require rigor calibrated by the nature of the data, but it need not be an ordeal, as I will show. The first question is, why change? Although not the focus of this video, I will share that our data work has gravitated towards Databricks for the reasons on the screen. In a nutshell, its ability to unify. You see, the job of data is to describe the business, say a patient's visit details along with their X-ray radiology. These distinct data forms led to different systems, the structured data in databases and the unstructured in blobs and files. But the data needs to be understood as a whole, so something else must do that. Often that's the business application, resulting in a point solution and further fragmentation. What we want is the data infrastructure to provide the integrated whole, to tie together all the information about a single entity, whether it's a customer, a product, or in this case, a patient. And that's Databricks. There's a final third constituent that Databricks excels at, derived or algorithmic data. For example, formulating the diabetic risk of a patient or deducing the sentiment of a customer's last interaction, thereby leveraging the full potential of the data. So here at CTI Data, even when dealing with just SQL data on a project, our recommendation is to future-proof its value by using Databricks. Okay, back to the mission. The data I will migrate is nearly 5 million de-identified patient diagnoses, which we imported into Snowflake from the real-world Mimic database provided by a large Boston hospital to support advances in clinical analytics. We used it to develop ICU patient acuity scores. It's the same idea as analyzing customer purchases to predict behavior or financial transactions to detect fraud. We will utilize Parquet, a highly efficient storage structure, as the intermediary to Databricks. The process has 4 steps. First, set up an Azure cloud container, then instruct Snowflake to reproduce each table as Parquet objects in the container, then have Databricks pull the objects into Unity Catalog, and finally run simple validations. You may also refer to our blog, which explains the process in more detail than I do in this video and includes a link to the code. Right, let's dive in. Here's the patient data in Snowflake. 67 tables, 431,000 admissions. Think of an admission as a transaction. In the business world, this is the same idea as a customer order. 4.7 million diagnoses. These are coded in the admission. The same idea as the product codes in a customer order, and 313 million charts. These are text descriptions, the same idea as the delivery instructions for a customer order. I've just run this script to obtain the exact diagnosis count for cross-checking later, and I have it noted in the margin over here for convenience. Okay, let's get things set up. First, we need the Azure container to hold the Parquet objects. Our code will require the name of this container and an access token, which I've already generated and stored in Databricks secrets, as you'll see later. Now let's jump over to Databricks. Here's the compute for our code. It's a tiny cluster, the smallest possible, good enough for our needs. Let's look at the SQL service. It's also tiny, and it's serverless. The code doesn't need it, but I'll use it to show how it replaces the Snowflake experience later on. Now it's showtime. Let's see the code. We're in the Databricks notebook. It's based on Jupyter and feels much the same. The code action starts here. We fish out sensitive access credentials for Snowflake and Azure from Databricks secrets. The blog describes how they were stored there. Sidebar, as you can see, secrets are always redacted in the output window. Now we can define our endpoint structures. Here's the Azure container name from earlier. And here, 2 variables that control our data administration. SnowStage defines the stage name in Snowflake to hold the Parquet objects. I've called it Databricks Import. DBX Schema defines the Unity Catalog schema name to receive them. I've called it PatientImport.Silver. The next 2 cells instantiate the connections to Snowflake and Azure. With the connections up, we instruct Snowflake to create the staging area. This only needs to be done once, and because I've run it before, we got this response. Similarly, we instruct Databricks to create the catalog schema. Again, this is a one-time deal. Although unnecessary, it's nice to see the web app of both products confirming their presence. Here is the Databricks import stage, bouncing over to Databricks, and here is the patient import catalog with the new silver schema. Okay, that's the first step done. We have the environment prepared. Now the second step, export the Snowflake tables to Parquet. Here's the initial list of Snowflake tables. We run the cycle for each, setting table name accordingly. And we're starting with the diagnosis table. Now the big moment, transferring the first table from Snowflake to Parquet. This amazing expression converted the Snowflake diagnosis ICD table into a series of compressed Parquet objects named diagnosis ICD with a sequence number suffix, all stored in an Azure folder also called diagnosis ICD. And look at the row count. Good news, it mirrors our earlier query. We can inspect the container. The Snowflake view of the stage and the Azure view of the container shows 4 Parquet objects were created. That completes step 2. Now step 3, transfer the Parquet objects to Databricks. First, we create the receiving table in Unity Catalog, and then run the transfer. This performs the exact reverse of earlier, reconstructing the diagnosis ICD table within Databricks by providing the folder name of the Parquet objects. Again, notice that the row count matches. That's it. Step 3 is done. The next few cells inspect data type equivalents and further row counts, which I call step 4, simple validation. I'm going to skip them for brevity. The same process is repeated for the remaining tables. Obviously, in a project setting, we'd automate this along with the validation checks. That's it. In 4 steps, we have transported our clinical Snowflake data to Databricks. Now let's explore what this means. In Databricks, Unity Catalog is the universal front door to all information. Let's peek at the structured data we just dropped in. Here are our tables, along with a helpful GenAI starter description of the schema. Let's look at the diagnosis table. Again, helpful GenAI starter descriptions for the table and its columns. I encourage you to pause the video here to read them. It's impressive how GenAI is seamlessly integrated. As I mentioned at the beginning, we're working with real clinical data. Let's see how Unity Catalog with Databricks SQL allows us to explore it. This SQL returns the top 4 DRG admissions for pneumonia patients, along with ICU transfers for all of last year. On the right side is Snowflake, and on the left is Databricks, with the same SQL and the same results. Critically, the data retained complete consistency of field values and interpretation, ensuring correct relationship cardinality, filtering, and aggregation handling. These kinds of business queries are an essential part of validation. How about that count we got from Snowflake in the beginning? Here's the same in Databricks SQL. And again, a perfect match. Unity Catalog also underpins the native GenAI capability of the Databricks Genie natural language interface. Here is that same pneumonia data requested in plain English. Let's briefly walk through the exchange. I started by asking about the information available with examples. Notice the answer is framed in business terms rather than technical database labels. I then asked it to tell me if there is anything else, and it provided a complete review of the tables, again in business terms. Then I asked for the pneumonia list, and I was told I neglected to provide a time frame. So I clarified the time period and got the results. Unity Catalog is also a data federation service, so Genie could also be asked to interact with our original Snowflake source data. As I said, Unity Catalog really is the front door to all your data, regardless of where it resides. Finally, we'll have Databricks SQL respond to an external client by exploring the new tables using dbeaver. We see this connection is to Databricks. Here's the metadata for the tables, including the GenAI table descriptions. And this connection is to Snowflake and the legacy Snowflake tables. Look how the Snowflake data types have been converted. For example, Snowflake's default number 38 has become decimal. The type conversion process was handled via Parquet. There are Snowflake-specific data types that do not straight convert, for example, the geospatial data type. For these situations, conversion logic will be necessary. Now we'll ask dbeaver to interface with the data by looking at a table. Let's try the diagnosis coding table. As you can see, the serverless Databricks SQL engine is handling the client data interactions cleanly. Keep in mind that this is just a piece of the puzzle. We've illustrated the transfer of data that follows ANSI SQL data types. There will be data that is not ANSI standard and may need logic to convert. Furthermore, to retire the legacy data platform, you will need to rewire the end-to-end data pipelines and address SQL logic differences. While this is a devil-in-the-details undertaking, Databricks provides BladeBridge to analyze the code, map out the dependencies, and generate converted code for review, making the work manageable and expedient. We recommend a process that is data product-centric, with each product migration initiated from a prototyping and discovery phase, each migration laying the foundation for repeatability. That concludes our demonstration. I've left the key modern data platform features on screen for your review. Take the next step and discover how CTI data can quickly amplify the value of the Databricks Lakehouse platform for your data and AI needs. You may contact me directly at kurtr@ctidata.com or request a meeting at ctidata.com/migrating to Databricks SQL. Thanks for watching.